take a minute, see if you can figure this out. Is a blueprint something that describes all? No, a blueprint is something that describes all instances. Does that belong to the class or is that an object? Something that is instantiated with a new operator, is that an object or is that a class? Something that has values unique to itself, is a class or an object? You get the idea. Figure it out. Which one is it? Then, let's pretend that you were with someone. What the heck is this? When the chat be used? You ready? Pause. Restart. All right, a blueprint that describes all instances. A class is essentially a blueprint. That's what it does, is it is the blueprint for creating all objects. And when you instantiate a new object, that means creating it with a new operator. You're creating a new object. You're not creating a class. An object has properties. Students have names unique to themselves. Okay, they may have the same name, but it's their name. It's not the class's name. Static methods generally belong to the class, but you know an object also has access to the class, so it can also use it. Something that's denoted with a capital letter. Hey, we start all the classes with capital letters. You can see right up here. Okay, the object's with a capital letter here. But in our annotation or convention for coding up identifiers, identifiers for objects are lowercase, identifiers for classes are uppercase. Something that defines a type, well, that's a class. A class is a type. Fraction that we made in our last video is a type. And we'll have other types like Excel engine, that's a type. Something that is passed by reference, objects are passed by reference, the other option is passed by value. The this keyword is going to be used to differentiate between instance variables and variables in the method. All right, we got a little more object-oriented programming to go. This will be short. I promise you won't suffer too much today. Mostly abstractions where we're going to cover. You know, we've covered state and behavior quite a lot, so I'm not going to do too much about that. We need to know the difference between an object and a class. It seems simple. You go, Mr. Stride, why do you keep beating me over the head with that? I think I got it already. Well, get ready for the stick. It's coming again. And then we want to know what an object is, what it has, and what it does. And this will be a repeating theme as we keep going. So let's look at a blueprint analogy. If we had an iPod and it has a blueprint, this blueprint on this side, I'm not sure that, I think that looks like a house instead of an iPod. But we would use a blueprint to create an object, an instance. Now, if I were to give a blueprint to an engineer, they would use that to create something. That would be the class. When I actually create an iPod, I have 3 iPods here, this one, and this one here, at least on the screen. Look, this one has a song, 1 Million Miles, and I'm not going to sing it. The volume is pretty high. Okay, but then we got discipline with the volume is much higher over here. 3 different iPods. They have different state. They have different volume. They have different battery life. You know what? They all have the same behavior, though. Do you see that? They all have the same behavior, and all that behavior is defined in the blueprint. We could take this a little bit further with cars. Cars have blueprints that you build a car. Car has a color. Car has the amount of gas in the gas tank. And these are things, these are state that belong to the car, not to the class. If I were to ask a blueprint how much gas is in the car, the blueprint would say, I have no idea what you're talking about. Will you please get off those drugs? I have no idea which car you're talking about. But if I ask the car how much gas is in your tank, then it can tell you, okay? So if I can't ask the blueprint how much battery life do you have left, it doesn't know what iPod I'm talking about. Abstraction. Abstraction and encapsulation are used synonymously a lot, and for all intents and purposes, they're pretty much the same thing. There's some subtle differences though. An abstraction is a concept that it is distancing between the ideas and the details, right? I have an idea, but I don't know how it's going to be done, and so I'm just going to abstract that away with a class. So fraction, when I created the fraction object, we abstracted the concept of a way of a fraction. We created it with a class. I don't know how it's going to be implemented underneath. I don't know how you're going to add and multiply. I mean, that's just mysterious to me. So it's abstracted away. With an iPod, you have no idea about these internals here underneath the side. You don't have any idea how this stuff works. All you know is it has, well, gee whiz, I don't, what is this thing? This thing is ancient. It's a brick. All right, it's an old iPod. You may not have ever seen anything like it in your life. I think we need to update this PowerPoint. But this is an iPod. You know how to push the buttons. You know how to work with it, but you don't understand the inner details. That's basically what abstraction is. I get the idea of what it is. I just don't know how it works. An iPod is what? It's an MP3 player. This is going to get into inheritance later on. We want to know what an iPod is. It's an MP3 player. All iPods are MP3 players. And so we would say that the class is a type of MP3 player. An iPod has, this deals with the class or the object. Which one? Class, object, class, object. It's going to be the object. The object has certain songs, current song, volume, battery power. And what does it do? That is defined by what? Is it defined by the class or the object? I didn't hear you there. Try it again. Oh, yes. Okay, yes, defined by the class. And so what an iPod does, are its methods, so it can play a song, display available songs, and recharge the battery. All right. So how do we invoke the behavior on these guys, on these objects? We use the dot operator. So like on a string class, when we take an object from type string, I can do the identifier name dot to lowercase. Do you know how it works? How about scanner? Do you know how scanner works? You don't? That's fine. You don't need to, and you don't really care because it's abstracted behind the string. It's abstracted behind the scanner. You just know that it's going to do the work, to lowercase for you. So we had that fraction class. Note here, look at this. Look at this. I changed the implementation. I changed the numerator to big integer instead of integer. How cool is that? That would mean that I'm able to do more things with my fraction class. I changed the implementation. All this stuff would be different internally, but the way I use the fraction would remain the same. I'd still multiply. I would still add. The behavior is the same even though the implementation changes. That's the distancing between the ideas and the details. That is abstraction. All right, that's it. I told you to be short. Go do your homework.